So in the last video, if you remember, we discussed something called dependency injection. So what does it mean? Well, dependency injection is a software design pattern that allows objects to decouple from their dependencies and accept objects that they depend on from outside. And in Flutter, there are two main ways to achieve dependency injection in Flutter. The first one is manual way and the other is using some dependency injection library. So the manual way is passing the dependencies to the objects through their constructors. Like when we take the instance of an object, for example, in this case, in case of auth qubit, when we take the instance of the auth qubit, so we have to manually pass its dependency. So this is the first way of the dependency injection. But it can be cumbersome if we have many dependencies. And the other way, as I explained, is using a dependency injection library. There are a number of dependency injection libraries available for Flutter, such as Getit, which is the one we will be using for dependency injection, and the other one is Injectable. The Injectable give us a way of generating the code of this dependency injection using the build runner and also other injectable libraries. These will be found in the pubdev package manager. And the advantage of these libraries is that these libraries can manage singletons, lazy initializations, and offer more organized way to handle the dependencies other than the manual way, especially when the application grows and the number of dependencies increases. As we have here, the auth qubit depends upon 3 dependencies. So dealing with this on a manual way is not recommended, because this can be cumbersome. So before going for understanding the dependency injection a bit more in depth, let's talk about some of the benefits of the dependency injection. As you might already have some idea of dependency injection as I explain things, so dependency injection benefit is reusability and maintainability. With dependency injection, the classes are not tightly coupled to the specific dependencies, and this makes it easier to reuse the code in different contexts and change the implementation without modifying the dependent classes. And also it helps us in testing and keep our tests in isolation. But on the other hand, if you don't use the dependency injection, there would be the tight coupling everywhere between our classes, as the auth qubit is tightly coupled with these 3 dependencies, and whenever we have to take the instance of the auth qubit, so we must have to pass these dependencies to use the methods or the functionality of this auth qubit. So we will be using the Getit service locator for the dependency injection in our application. We have added the package in the dependencies here. We will be using that Getit. It's the service locator used for dependency injection. It gives us more organized way to manage the dependency injection in our application. So first of all, to implement the dependency injection in our application and decouple the classes from their dependencies, we have to create in the lib directory the first dart file main injection container. This would be a dart file, and inside this we will take the instance of the Getit and will store it in the global variable called SL, so that we will use that SL variable in different features injection files to inject each feature dependencies. For example, in case of user feature, we will inject its dependencies in the user injection container file that we are going to create after some while. There would be the need of this SL variable, which is globally created in the main injection container. So next, inside the main injection container, we are going to have a feature method of named init, which is awaiting the user injection container. Now let's go for creating the user injection container. So this would be located directly inside the user feature. So inside the user feature, we will create the user injection container where all dependencies of the user feature classes will be injected. Hit enter to create that. So we got that user injection container. So here we're gonna have the user injection container method, and let's go for the main injection container and import this in here. Now let's go for the implementation of the user injection container and open its body. So for the user feature, we're going to inject the qubits of the user feature, the use cases, and lastly the repository and the data sources. So first of all, let's go for the qubits injections. So here we will call the SL, which is the global variable, and we will go for importing it from the main injection container, and then from this SL we will register the factory and will pass the type of the first qubit that we want to register, and we'll pass the auth qubit, and this is going to return the qubit instance of the auth qubit, which is depending upon 3 use cases. And here we will do it like this, put the semicolon in here, and for the use cases we will do sl.call, and also for this sl.call, and also for this sl.call. So what does that mean? First of all, let's discuss what is the register factory and why we are registering factory for the auth qubit. And then you will discuss the sl.call in that case also. So when you register a type with the register factory, as we have done for the auth qubit, a new instance of that type is created every time you request it from the gated. Like when we request the auth qubit instance that is registered as a factory inside the user injection container, so every time we request it, this will give us the new instance of that class. This is particularly useful when we need a fresh instance of a class every time we access it, and this ensures that no stat or data is shared across different parts of the application. And in case of qubits or blocks, often maintain stat, and registering them using register factory ensures that each part of our app gets a fresh qubit instance with its own unique stat, and this way the different parts of our app won't accidentally share or modify each other's stat. So this way everything will be isolated and fresh. So that is why we're registering the auth qubit as a factory. And now what does that sl.call means? So that the sl.call is a method or perhaps a custom extension of gated to retrieve the registered dependency. So every time when you do sl.call for the getCurrentUID use case or any use case in here, it will look for the already registered dependency in the gated, so that if it found once, it will get directly that dependency and will pass it in the auth qubit, so that we don't have to explicitly pass the auth qubit, the getCurrentUID dependency ourselves. And same will be for isSignin use case and also isSignout use case. So later, when we were to provide the auth qubit on the root onto the root to make it available for all the descendant widgets, so we will directly call to the dependency injection container, and using that auth qubit type, we will take the auth qubit instance, and the other dependencies like these will be passed from outside that we are going to register after some while, so that we don't have to explicitly pass dependencies when we were dealing with the classes like the auth qubit and the other that we are going to create in some while. So now let's go for registering the other qubits the same way. So we got the user qubit, get single user qubit, credential qubit, and lastly the get device number qubit registered using the register factory. So again, every time one is requested will give us the new instance, so that different parts of the app won't accidentally share or modify each other's state, and everything will become fresh like that using the register factory method from the SL service locator of using it, so that our user feature qubits are successfully registered. Now it's time to register the use cases, because when this sl.call is called for each use case dependency is for the qubit, so it will look for the already registered dependencies in the gated. So if we don't have one, so it will throw the error, will give us did you forget to register the specific dependencies inside the gated, so that we have to register these also. So for the use cases, we will do sl.registered lazy singleton and passing the type, for example, get current UID use case, and is going to return the get current UID use case. And for the repository, this time it will go for SL. So again, for the repository, this will again start looking for the register repository, which we are going to register also after registering the use cases. Here I have commented out, we are also going to register the repository and the data sources. So when you call the sl.call for the repository, it will also start looking for the already registered repository of the user that the getCurrentUID use case is using for achieving what that specific use case is doing. So now what does that register lazy singleton means? This method registers a type as a lazy singleton. This means that the first time when you request this type from the Git, it creates the instance, and for all the subsequent requests it will return the same instance. The lazy part means the instance is not created at the time of the registration but only when it's first requested. The use cases are generally the stateless. They contain the business logic that should behave the same way regardless of where or how many times it is called. So since they don't maintain any internal state specific to their invocations, so there is no need to create the multiple instances of the same use cases. So by registering them as lazy singletons, we also ensure that they are only created when they are first requested, which might be beneficial in terms of performance and resource usage, especially if you have use cases that might never be called during the particular app session. So now let's go for registering the use cases the same way as we have done for the get current UID use case. So this way all the use cases are successfully registered as lazy singletons and their instances will never be created until they are requested, and when they are requested that instance will be used for the lifetime of the app because they are registered as lazy singletons. So that it's done for the use cases. Now it's time to go for the repository and the data sources. So the repository will also be registered as a lazy singleton, and now whenever the user repository abstract class or a contract is requested, so we will return the user repository implementation, and then for its dependency the remote source will go for sl.call to look for the registered remote source dependency. So it's not yet, so let's go for doing it also. So we got the user remote source also registered, which is when requested we'll call the user remote source implementation, and then for the auth and the firestore dependencies we also do sl.call to look for the auth and firestore external dependencies. So for the auth and firestore we are not going to register them like that. That is because we are going to need the auth and firestore in all of the injection container for the status chat call. So for that we are not going to register them again and again in their specific injection containers, but instead we could directly register them in the main injection container. So whenever the init method is called, so that will only be registered once. So first of all we will take their instance of the auth and firestore and then register them as lazy singletons directly inside the init. Now one last thing that is remaining is to go to the main.dart and then go for import the main injection container as di, which shortly means dependency injection. And then before running the app we will do, first of all, make it this main asynchronous and go for await di init. So that is how, using dependency injection with the help of Git service locator, we have decoupled the classes from their dependencies and they accept the dependencies from outside while creating the instance. So with that, when our app starts, this will directly call the main injection container, and so this will call the user injection container, and all the dependencies will be injected directly from this user injection container, so that whenever there is need of the auth qubit, so simply you will request on just using the type and will access the instance of that, and these dependencies will be managed by the Git service locator. So whenever our app starts, we will directly call to the init and our dependencies will be adjusted accordingly. So whenever there is the need of a specific class anywhere in the UI, so we will directly call that from the injection container without passing the other dependencies, as the dependency care is taken by the Git service locator. So that is how, using dependency injection with the help of Git service locator, we have decoupled the classes from their dependencies and they accept the dependencies from outside, and while creating the instance we directly call the register class by using the type with the help of Git service locator. And you will see this in the next video when we will be able to provide the auth qubit and also the other qubits on top on the root here on the material app, so to make them available to all the descendant widgets because we're going to need them for loading the data and also to call the methods from that, doing the block provider.of contexts and using the type of the qubit access the methods. So for that we need to have the qubits on the root so that we will access them from the specific context down the tree. This is also what we are doing the inherited widget. So by providing the qubits on the root, so we are making them available for all the descendant widgets. So if you want to learn more about the inherited widget, I already have created a detailed video on this topic, so you can go for this video and learn more about the inherited widgets from more visual examples in this video. So that was it. We have implemented the user injection container and have injected all the dependencies so that whenever we need them, we will simply request using their type, and all the dependencies will be managed outside by the Git service locator, and we have managed dependencies this way. So in the next video, we will finally go for creating a Firebase project directly, and we'll set up it for Android and iOS directly, which is going to take very less time creating the Firebase project and linking with the Android and iOS. And then lastly, going for all the methods to bind them with the UI to make the user feature functional within our WhatsApp clone, like to authenticate the user and modify its data. So that's it for this video. If you have any questions about the dependency injection and you think if there is something missing, please let me know in the comment section. I would love to see your feedback and will give your comment a heart. And also make sure you like the video so that the YouTube algorithm will spread it and other people can find it easily. So that way you can also help other people to learn real app development from this bootcamp. So that's it. See you in the next one.